Hello everyone, today I will show the research about Shanghai Composite Index. I will use the data about close price and open price monthly from 2007 September to 2017 September. The Shanghai Stock Exchange opening in 1990 with 8 stocks and 12 bonds. Until now, in 2017, it works for more than 1,000 companies, and it has more than 1,000 stocks and more than 10,000 bonds. Actually, for the investors and organizations, they always use the stock index to make decision, and stock exchange provides the current and 1 day, 7 day, and 30 days historical data and plot for the investors to make decisions. Now we see the correlation between close price and open price. We see they have the similar pattern. They have the same intervention and the same trend and changing YS. It looks there isn't a various similarity here, and we use the call function to see there is a stronger correlation about 0.9 between them. And then we will see the CCF. There are several significant lags here. That means there is a cross correlation between them. And after providing only one significant lags here, that means there is a real correlation between them. And there isn't evidence to conclude that there is a spurious correlation between them. Then we will fit it models. First, we will fit it distribute lag models with the basic one and the polynomial and co-care as a different p and q value about the autoregressive distribute lag models. Within the fitted distributed lag models, the result and the diagnostic check for them. For example, for this one, we see a good adjusted R-squared value about 0.85, and the p-value here is nearly equal to 0. It means this model is significant. But for the coefficient, most of them are insignificant. And for the VIF, we see only this one is less than 10 and others more than 10. It means there is a problem about this fitted model with a collinearity. And for the check residues, we see only this one is a slight significant lag in the ACF plot. And for the normal distribute, only few values left outside the 95% confidence interval. And for the BG test, the p-value is small, so we think the residue here is not a white noise. After that, we focused 10 steps ahead with the distributed lag models. We see the basic one and the polynomial one have the same value there, and this one is reasonable. But for the cookie, it decrease in the 10 steps ahead, and for the autoregressive, it has a large changing ones there. We think they are not reasonable. Then we will fit it the dynamic linear models. First, we throw the X12 function to see the green and blue lines here. They are not similar, so that means there are other factors like changing y-as affect these series. And the blue one is similar as the black one. It means looks like the seasonality factor doesn't make sense for this series. So when we fitted models, we will fit a model without seasonality factor. The fitted model result looks like before, and the value here looks good. But for the VIF, we see all the values less than 10. That means this one resolves the problem about collinearity. And for the residues check, we see there is a problem about the normal about the random work. It might affected by the intervention. But for the ACF, we see all of these are insignificant. It means there isn't correlation left in the residues, and only few values left outside. But for the BG test, the p-value is still small, less than 0.05. So it means that this fitted residues is still not wide. Then we compare the dynamic linear models. We see user function here, and we see the model 2 and model 5 are better than others. It solves all the problem. And for the model 5, there isn't value for the VRF because there is only one coefficient for this model. And then we will fit it values and forecast with model 2. We see this one looks good. It captures the intervention and the changing as the change there, but it still can't capture some information in the original data. And for the forecast, it starts with a big jump. It might affect by the intervention, but we think this one isn't reasonable. Then we will see the general pattern of closed price series. We see there isn't above average high and low repeat values in the different months. And for the ACF, we see there is a decay here and a no repeat pattern, so we think there is insanity here. But for the PACF, the first lag is significant, so we think there is an autoregression here. And then we will fit it model with exponential smoothing model with Holt model. The result shows like this. It shows that it's AIC, BIC, and AICC, MASE value here. We will compare them later. And the residues check looks good. It still kind of solve the problem about the intervention part. It's not random. And for the ACF, all of these are insignificant. And for the normal, it's just a few left outside. Then we will compare them. We see they are similar, but for the green one, looks better than others. Based on the information before we will fit the state space model, we will consider the multiple error, multiple cheat here. And as we see, the MMN get return a good result about that. And actually, the auto system give a pattern, the model without trend, but we see in the original data there is a trend there, so we think our decision is better than that. And then we will use our result to fit the model with different criteria to get the different result. And we see in the check residues there just a slight lag here in the ACF, and it still can't solve the problem about the intervention. It's not random in this part. And we see the 4 and 5, they have the same value about different measurements. It means the depth doesn't make sense for this one. And we see the MMN has a good result about AIC, AICC, and BIC. But for the MASE, the last one gave a good value because it is smaller than others, but looks all of these value looks similar. They have a slight difference, so we think MMA is better. Then we fitted the forecast value with the state space model MMN, and we see it looks reasonable. Just start with the last above average value, and all of forecast value are similar with a slight difference between them. Finally, we will see the simulation and predict density here. In the first one, we see the simulation 10 steps. We see the limiter here. And in the second one, we see the probability of one step ahead less than 2500 or greater than 40 hundreds are small. So that's all the information I saw today. Thank you.